Hello and good day, geometry. We are here talking about PO41, which is special triangles, 45, 45, 90 triangles, and 30, 60, 90 triangles. And when we talk about 45, 45, 90, and 30, 60, 90, what are we referring to? Anybody have a guess? Yeah, the angle measures, right? So we've already talked about the Pythagorean Theorem, and that if we know two sides of a right triangle, to solve for the third, the Pythagorean Theorem is a very efficient method to use. Set up your equation, a squared plus b squared equals c squared, and if two of the sides are known, then it's just the algebra required to find the length of the third. However, sometimes you only know one side of a right triangle, and in that case, you need to use sine, cosine, tangent, unless you have a special right triangle, which is either a 45, 45, 90 or a 30, 60, 90. And the reason why these are considered special is not only are they fairly common, but also the ratios of their sides are fairly easy to work with. Whereas in sine, cosine, tangent, if we have a 71 degree angle and a 19 degree angle, those ratios aren't very easy to work with. But we'll worry about that in PO42. For now, let's talk about these two special types. Okay, so a 45, 45, 90 triangle, its side lengths are in the ratio of n to n root 2. The side lengths of a 45, 45, 90 triangle are in the ratio n to n root 2, which means that two of the sides are the same, and then that third side is whatever that length is times the root of 2. And you can probably guess when we draw out a 45, 45, 90 triangle. I'm going to try and draw it as accurately as possible here. Okay. Label our sides, 45 and 45. Can you guess which two of those sides are the end sides, are the same length?
The bottom and the height, or the width.
And what do we call those in a right triangle? There's a special name we use for them. What is it? Well, legs, yes. Okay. And they're the same because they're both opposite congruent angles, right? This is technically an isosceles triangle. It's got two congruent angles, and so the sides opposite those angles are going to be congruent. So those are our two n sides. And the hypotenuse is going to be n times the root of 2, okay? Which is not 1. Root of 2 is not 1. Remember, the root of 2 means what number times itself equals 2. It's like 1.4 something, and it goes on and on and on. But someone in the money group said, oh, it's just 1. Well, no. If it was just 1, then we would just write 1, but it's the root of 2. So anyway, so here's the application of it. If you are given a 45, 45, 90 triangle, and I tell you that one of the legs is 12, with only that piece of information, one given side, and the fact that it's a 45, 45, 90, you can tell me the lengths of the other sides. What's the length of the other leg? 12. It's the same. What's the length of the hypotenuse? 12 root 2. And please do not type 12 times root 2 into your calculator and put the decimal answer. We want this to be an exact answer, so it is going to be 12 times root 2, written as 12 root 2. Okay? Question so far? All right. For a 30, 60, 90 triangle, the ratios are n root 3, and 2n. n root 3, and 2n. An example of a 30, 60, 90 triangle. See if I can draw a straighter line on that. One of the legs will be longer than the other. Label our 30 and 60 degree angles there. And 30, 60, 90 triangles will always hold a special place in my heart because has St. Vincent ever been accredited that you're aware of? Do you know what that process is? So every 7 years, a school needs to be accredited, which means that a team of teachers from other schools come in and they talk to all the teachers, they talk to the principal, they talk to some parents, they look at our mission statement, our website, our curriculum, test scores, everything, and they kind of say, here's what you do really well, and here's what you need to work on. And then you've got, like 2 or 3 years to kind of work on what they suggest to work on, and they check and make sure everything is, it's basically designed to make sure that schools are being the best they can be. Anyway, so my first year teaching, we happened to be being accredited, and part of that was I was observed. And that particular day, I was teaching 30, 60, 90 triangles, and I taught it wrong. And first year teacher, teaching it wrong, I realized it like halfway through, but I'm being observed, so I don't want to admit it. Luckily, the person observing me wasn't paying attention or didn't know, math and didn't know I was teaching it wrong. But then when that person left, I had to stop. Okay, folks, tear out the paper that you just had, erase everything from your mind, throw it away, and we're going to start over again. And so every time that I teach these, consciously making sure this is the right way. This is the right way, because I don't want to make that same thing again. So our short leg, the leg opposite our 30-degree angle, is side N. And you might think it would make sense that the long leg is our 2N side, because 60 is twice 30, and so N, 2N, but it's not. The long leg is our N root 3 side, and the hypotenuse is the 2N side. So the mistake that I made was I switched the long leg and the hypotenuse. I said the long leg was 2N, the hypotenuse is N root 3. Why is that wrong? Why does the hypotenuse have to be the 2N side? Yeah.
Because if you type in your calculator the root of 3, it's 1.7.
Yes. The root of 3 is less than 2, meaning whatever N is, if I multiply that value for N by root 3, and I multiply that same value for N by 2, it's always going to be greater when I multiply it by 2. And the hypotenuse of the right triangle has to be the longest side, therefore it has to be the 2N side. I wish first year teacher Schultz would have known that, but oh well. So anyway, looking at application here, here's a miniature 30, 60, 90 triangle. There's 30 degrees there, 60 degrees there. If I tell you that our N side is, let's go 10, what's the length of our long leg? The one opposite the 60-degree angle. Julia? 10 root 3. And the length of the hypotenuse? 20. 2 times N. Okay? Questions so far? Doing okay. All right. So these are the ratios that you want to put on a help sheet for a 45-45 and a 30-60-90 triangle. You can also put this down so you can actually kind of label the sides, which one is the N side, which one is the N root 3, which one's the 2N, and so forth. Okay? All right, so moving down to where we practice a little bit here. I'm going to put in the angle measure for you, and I want you to go ahead and label sides A and B. Find the measurements for A and B. I'll pause the video. We'll come back to it, correct it. But this first one is going to be a 45-45-90 triangle. This one is a 30-60-90 triangle. Another 45-45, and another 30-60. Okay, I shall pause. We shall return soon. Work in the meantime. This one. All right, and we are back with the video. Here are the answers for those first 4, as well as a bonus section on how we could use the Pythagorean Theorem to prove that these values are correct. We haven't really had much experience with multiplying roots, squaring roots before, so we didn't really get too deep into it, but there's the math behind it. Okay, so on the second page now, you are given a 45-45-90 triangle, as well as a 30-60-90 triangle, and then 2 charts. Everyone loves a good chart. Okay, so for this 45-45-90 triangle, we'll start there. Each column is a new triangle, or a different triangle. So for this one here, I'm giving you a 45, 45, 90 triangle with a leg length of 7. And you're to fill in the other two values for this column for B and for C. And so with a leg length of 7, this triangle would have a B length of also 7, and a C length of 7 root 2. Okay? Then you move on to the next one, which is a different triangle, right? This time the B value is given to you, which is 11, which means that side A is 11, and side C is 11 root 2. And then things get fun in the next one, don't they? Because that hypotenuse side, which has that root 2 as a part of it, now is a whole number. It's 10. Okay? So here's going to be your introduction for how to work with roots with multiplication and division. What we have here is a 45, 45, 90 triangle with a hypotenuse length of 10. Okay? Now, this is where knowing these ratios is very, very helpful for you. What's the ratio for the hypotenuse of a 45, 45, 90 triangle? What's the value of the ratio? Sorry? Well, n to n root 2, right? Which the hypotenuse side is the n root 2 side. So we can set up the equation that n root 2 equals 10. Right? If the hypotenuse is the n root 2 side, and that is 10, then n root 2 must equal 10. Okay? Now, because we don't want our answers in decimal forms, we're not going to take out our calculator and divide 10 by root of 2. Instead, we're going to use algebra. How do I get n by itself here? If I'm multiplying n by the root of 2, how would I undo that to get n by itself? We're not going to square the root because that would mean we have to square n also. We kind of got into that in the last one. I mean, if n was under the root also to get n by itself, then we would square it. But n being outside of the root, and knowing that this says n times root 2, how do we get n by itself? Sebastian? Not multiplication, what are you going to say? We're going to divide by root 2. This would be the same thing as if we had, 4n equals 12. And I said, how do we get n by itself? You'd say, well, you divide by 4, because that's the opposite of multiplying by 4, right? Well, here we're multiplying by root 2. So the opposite of that is dividing by root 2. So we're going to divide both sides by the root of 2. In algebra right now, we're learning that anything divided by itself equals 1. That includes roots. So that root 2 divided by root 2 cancels out. And n is by itself. Now, 10 divided by root 2 is not root 5. It's not 5. We can't divide them because one is outside of the root, the other one is inside the root. So we just leave it as 10 over root 2. Can't go any further. So our length for side A is 10 over root 2, and the length for side B is also 10 over root 2. Does that kind of make sense? I'm going to keep things fairly basic on the test. If I give you one that involves this type of math, because we haven't done it before, it'll be an extra credit type question. But that's how you would handle it. You would set that value for the hypotenuse equal to its part of the ratio, in this case n root 2, and get n by itself. Let's look at the next one, because that one's kind of funky also. It's got that root 5 for the value of A. So here's 45, 45, 90. The value of A is the root of 5, which means the value for B is what? Root of 5. And the value for C is whatever n is, in this case root 5, times root 2. So to find C, we're going to have to multiply root 5 by root 2, which this we can actually do because they're both under a root. What do you suppose root 5 times root 2 is? If you had to guess. Alex? You would be correct. Root 5 times root 2 is equal to root 10. And we're allowed to do that because they're both under a root. If we'd had 5 root 2, we couldn't go anywhere. Because one is outside of a root, the other one is under a root. They can't be multiplied. But if they're both under a root, kind of like terms, okay, then they're able to be. Okay? Let's look at the 30, 60, 90 triangle. Which one looks particularly fun to talk about? Knowing that side D is our n side, this triangle has been kind of tipped over on its sides. That short leg is always the n side, in this case side D. The long leg is always the n root 3 side, which is side E, and the hypotenuse is 2n side F. So based on those ratios and based on the values that are given to you in the table, which triangle looks particularly worthwhile going over now? Olivia? Yeah, ooh, that does look fun. Okay. 18 root 3 seems like it'd be easy to work with because it's got that root 3 on there. But then you realize, wait a minute, that's in my hypotenuse, not my long leg side. That's not going to be very much fun at all, right? So we're going to set this up the same way as we kind of set up that 10 as the hypotenuse for a 45, 45, 90 triangle. We know that 18 root 3 is equal to the 2n side. 18 root 3 hypotenuse, which in our ratio is the 2n side. And just like we did before, we're going to want to get n by itself. How do we do it? (18 root 3 equals 2 times n. How are we going to get n by itself? Julia? Divide by 2. Okay. So on the right side, that cancels the 2's out, which is exactly what we want. On the left side, we get this fraction now, 18 root 3 divided by 2. Sebastian? Yes. We're able to divide the 18 and the 2 because they're both outside the root. We couldn't do anything with 10 divided by root 2 over here because one was outside, one was inside. They're both outside. We can simplify these coefficients, and that gives us 9 root 3 as a value for n, because 18 divided by 2 is 9. Yes?
So does dividing the 18 by 2 get rid of it? And does that mean that you don't have to divide root 3 by root 2?
Correct. Correct. It's kind of like in algebra now, we're dealing with all these polynomial stuff. If we had 12x squared divided by 4, we would look at our coefficients. We would divide 12 and 4 to get 3, and there's nothing with x squared that we can do. So kind of the same situation there. Okay. So 9 root 3 is our n side, which in our diagram is D. Okay. So to find E, we're taking our value for n, which is 9 root 3, and we're multiplying that by root 3. So that's what that E side is. It's n root 3. Our n value is 9 root 3, so we're multiplying that by root 3. We've already tackled what root 3 times root 3 is earlier. That gives us root 9 We like the root 9, don't we? Because that's a perfect square. Root 9 equals 3. So we get 9 times 3, which equals 27. One like that will definitely not be on the test. Okay? That's definitely not going to be on the test. But that's how you would go about that one. Julia.
Would it be wrong if you kept it as 9 root 9?
Technically, yes, because it's not simplified. I'm not going to give it to you on the test, but if I did, if you had had this background in roots coming in, then 27 would be the only acceptable answer. Yeah, anytime that you do end up with a perfect square, it should be simplified. Another one you want to go over from that 30, 60, 90 bunch. Elise.
The one with the 12.
Sure. Let me erase all this stuff here. Okay, so the one with the 12, we're given side E, which is our long leg, so kind of drawing this out here. Okay, we're given that long leg side. And our first step should be to go get n, because once we know what n is, then we can just double it to get the length of the hypotenuse. So what are we going to set up? What equation can we use to relate that 12 to the ratio of the triangle? Gabby?
12 equals n root 3.
Good. 12 is the n root 3 side. So basically what we're saying is whatever n is, we multiply it by root 3 to get 12. And so this equation is going to allow us to solve for n. What value did we multiply by root 3 to get a value of 12? How do we solve for n? How do we solve for n? Yeah. Divide by root 3 again. Yep. So our root 3's cancel out on the right side. 12 divided by root 3 is not going to be any sort of 4, because again we're in the situation where we have the 12, which is outside of a root, the 3, which is inside of a root. Can't combine those. So our value for n is going to be 12 divided by root 3. And now we get the hypotenuse, which is 2n. We're going to want to multiply that value by 2. So we've got 12 divided by root 3, and we're multiplying it by 2, which when we write it out in fraction form, doesn't look too bad here. It'd be 24 as a numerator over what? Over root 3. Because root 3 times 1 is just itself. Okay? So our hypotenuse value is 24 over root 3. On the test, you can expect one like this. You can expect one like this. You can expect one like this, to where you're not going to have to deal with all these root operations. Okay? Unless it's an extra credit question. So if you can do these first 3 successfully, then you're looking good for the test. If you can do this one and this one and this one in the 45, 45, 90 triangle, you're looking good for the test. Just the basic understanding of what those ratios are and how to move from one to the other without all that root stuff. Sir?
So there won't be any that aren't like...
Unless they're extra credit.
Uh-oh.
I won't say no for sure, but unless they're extra credit. Okay. Why don't you do the first 3 in that 30, 60, 90 triangle? You'll have homework from the book also. But just do those first 3 columns just to make sure that you got 30, 60, 90 triangle down while I look at what I want your homework to be. All right, and just so you have them, the answers to that fifth triangle of 45, 45, 90, A and B are both 6. That's how we get a hypotenuse of 6 root 2. And then the first 3 columns are the 30, 60. E is 5 root 3, F is 10. Second one, our N side, D is 7, E is 7 root 3. And then the third one, with a long leg of 8 root 3, that means that D is 8 and F is 16. Any questions, comments, concerns, complaints, comments, congratulations, or criticisms? Very well. So PO42 we posted tomorrow. PO43 posted Friday. Test for funsies next week, Monday or Wednesday. Then test for realsies next week, Thursday or Friday. And that wraps up triangles for the year just in time for spring break. All right, with gusto, that's how you math.